Okay, so moving on to problem number 4. Problem number 4 is the same setup as the last problem. We're going to graph this function, and we're going to graph this function, which is what that says. Sketch the graph of each function. And then we're going to shade the region whose area is represented by this definite integral. So that's what we're going to do. And let's see. I'm going to sketch this function right here. That's just a linear function. So linear functions go back to algebra 1. And all you do is you recognize that minus 6 at the end. That's your y-intercept. So I'm going to go ahead and graph that. Let me do it in black. If you remember from algebra 1, this is your y-intercept. So that's your y-intercept. And your slope is what's in front of the x. This is your slope-intercept form, mx plus b. The number in front of your x is your slope. Well, you don't see a number in front of your x. It's a 1. So it's going to be a slope of 1. Which means to get my other points, I'm going to go up 1, right 1. So there's going to be a point right here. Because that's what a slope of 1, that's what you do. You go up 1, right 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. Or you could go down 1, left 1. But that's going to be the graph of x minus 6. It's going to be that right there. And we go up 1, right 1, right here. You don't need that many points. Obviously, a straight line, you only need 2 points. But I'm going to connect these points right here. Connect those. Connect these. Well, you know, it should be straight, but that's okay. And that's the graph of x minus 6. Okay. And now I'm going to graph this right here. X squared plus 5x minus 6. And I'm going to make the same assumption that I made in the last problem, which is that you're going to graph this by getting points that would be on that function. Now let's go ahead and do that. So I'm looking at x squared plus 5x minus 6. I'm going to get some points that are on that function. So I'm going to start plugging in some x's. Easiest one to plug in, of course, is a 0. And if I put a 0 into these x's, 0 squared is 0. 5 times 0 is 0. So if I put a 0 in, I get a negative 6 out. So that is a point on my function, and I will go ahead and graph that. 0, negative 6. Let me do a different color. Let's do blue. 0, negative 6, a point on the function. Next easiest point to put in is a 1, so I'll put a 1 in. And if I put a 1 into my x's, 1 squared is 1, 5 times 1 is 5, 1 plus 5 is 6, and 6 minus 6 is 0. So if I put a 1 in, I get a 0 out. And I will go ahead and graph that. 1, 0, which is going to be right there. And then I'll put a negative 1 in, because I know it's going to be symmetrical. And if I, well, actually, yeah, this one should be symmetrical. If I put a negative 1 in, let me see, is that right? Maybe it's not. We'll find out here in a second. If I put a negative 1 in, negative 1 squared is 1, so that's 1. Negative 1 times 5 is negative 5. 1 minus 5 is negative 4. So yeah, that's negative 10 actually. If I put a negative 1 in, I get a negative 10 out. Okay, so yeah, it's not symmetrical. If I put a negative 1 in, I get a negative 10 out. And I'll go ahead and plot that negative 1. Let's see. negative 10. I got a point right there. And let's go ahead and put a negative 2 in and see what we get. Because again, I don't know how many points you actually need. But I'll go ahead and put a negative 2 in there. And if I put a negative 2 in there... Oops, I didn't mean to do that. What I'm saying. If I put a negative 2 into my x, negative 2 squared is 4. Negative 2 times 5 is negative 10. Negative 10 plus 4. Did I say 4 or negative 4? I can't remember. Yeah, 4. So negative 10 plus 4 is negative 6. And negative 6 minus 6 is 12. So if I put a negative 2 into all of my x's, I get a negative 12 out. And I'm going to go ahead and graph that. Negative 2, negative 12 is right there. And we'll go ahead and do a few more. I put a negative 3 in. Put a negative 3 right there and there. I should get a negative 12. 9. Yeah, and negative 12. So if I put a negative 3 in, I get a negative 12 out. Now I'll go ahead and graph that. Negative 3. Right. Let me see. Make sure I'm doing this right. Yep, negative 3. 12 is right there. And we'll do one more. Let's do like a negative 6. See what we get when we put a negative 6 in. I'm not quite sure why I'm doing all these points. I don't think you need that many. But if I put a negative 6 in, negative 6 squared is 36. Negative 30. Let's see, negative 30. What did I put in? Negative 6, right? Yeah, if I put a negative 6 in, I get negative 36, 6. I get a 0. So if I put a negative 6 in, I get a 0. And I'll go ahead and plot that. You probably don't need that many points. I'm not sure how your tool works. You probably only need like 3 or 4 points. If that's how your tool works, and I'm assuming it is. And then you probably hit that tool and it'll connect your points. So I'll go ahead and do that. I did way too many points. You don't need that many points. So I get that function right there. And now, so that we did this part. Sketch the graph of each function. And shade the region whose area is represented by the integral. Okay. So let's go ahead and look at this. The integral is going from negative 4 to 0. So we need to be mindful of that. It's going from an x of negative 4, which is this point right here, to an x of 0, which is... where is that? An x of 0, which is about, it's going to be this point on this function and this point on this function. Okay. Let me just make sure that's good to go. Do they share the same point? Yeah, I think it's just a messy graph. Yeah, it's a messy graph. Your graph will be perfect because your tool's doing it. But on this graph, if you actually look at your graph, they should intersect at that point. The two graphs should intersect. Okay, so we're going from negative 4 to 0. Okay, going from a negative 4 to 0 between those two x's, which on your graph is these 2 points there. And we're taking the area, let me see, under this graph. You got to make sure you do this right. And we're going to subtract out the area under that graph. Okay. And finally, we graphed our 2 functions. And now we've got to shade the region whose area is represented by the integral, which is going to be this part in between right here. It's going to be that right there. And that is the answer to that one. So I'll go ahead and stop this video, and I'll start making some more in just a minute.